I'm John Melville from Vernier Software and Technology, and today I'm going to be talking to you about a really interesting experiment that looks at the metabolism of different types of sugars. Specifically, you can investigate the metabolism of monosaccharides or disaccharides or lots of different sugars, or what we would call carbohydrates. This experiment utilizes yeast, and it's derived from an experiment in our Investigating Biology Through Inquiry book. And you can do it using a CO2 gas sensor, but in this case, I'm going to be using a Vernier ethanol gas sensor. And this is a much more affordable way to actually do this investigation. All that you need is a Vernier ethanol gas sensor. You need something to collect the data with. In this case, I'm going to be using a LabQuest Mini and a computer. And then what I have here is my little fermentation chamber. It's just a little Nalgene bottle. I have some yeast that I've mixed up, and I have a solution of glucose. And in the actual lab instructions, it'll tell you how to mix up the proper solution of yeast or the proper amount of glucose solution or fructose solution or lactose solution, whatever you want. I'm just going to show you how to quickly do this experiment. So to set up the ethanol sensor needs to warm up for 5 minutes. I already have it plugged into this interface and it's been warmed up for 5 minutes. Now it's important that you realize that the ethanol sensor is never going to read absolutely zero. It will be close to zero. In this case, it's at 0.009%, and that's fine for this experiment, because really what we're interested in is the change in fermentation rate when yeast are supplied different types of sugars to consume and ferment. Now, I have already put a cap on this ethanol sensor. You just need a little piece of Teflon tape, and you coat the bottom of the sensor. You can see right here I have a little cap that comes off. You put a little piece of Teflon tape over the end, and then you put the cap back on. And that's just to protect the ethanol sensor in case you were to get it wet. In this case, the whole reaction is going to be happening in this little Nalgene bottle, and there isn't really that much water in there. We don't have to worry too much about it. The other thing that we're going to need is a little stopper, the split stopper. The split stopper fits right in the top of the Nalgene bottle. And what's really nice is when we place the ethanol sensor into the Nalgene bottle, you can see that it will fit right down in it. And we don't have to worry about it actually getting wet or anything like that. So I'm going to take this out now. Now it's going to be a little bit noisy because I'm going to actually have to use this little stir bar to actually move the vapor around in this little bottle. But first what I'm going to do is I have a little conical tube, and in this conical tube I have 5 mils of yeast suspension. This is just some yeast and some water. And then I'm going to feed the yeast 5 mils of this glucose solution. And actually, I'm just going to pour another 5 mils into here so that it reads 10 mils. There we go. Then I'm just going to cap it, and I'm going to invert it just 3 times. I like to invert it 3 times just so that I mix the yeast really well with the glucose solution. Then I pour the yeast suspension with the glucose into the bottle. Then I put the stir bar into the chamber. Put the ethanol sensor into the chamber. Real quickly before I start this experiment, I'm just going to change the units over here of the ethanol sensor in Logger Pro by going to the experiment menu and going to change units, ethanol sensor. And I just like to see this in parts per million. You can leave it in percent, but I like having it in ppm. And then now I'm going to turn it on. It's going to make some noise, and then I'm going to hit the collect button. There we go. And you should actually see a very good response within 5 minutes, but the experiment is actually set up to record for a full 10 minutes. So I'm just going to turn this off here, and I'm going to hit stop. So I've stopped this experiment a little bit early, just because you can see that you don't have to go to the full 600 seconds or 10 minutes to actually get good fermentation. You really should be able to see a really good fermentation rate just within the first 300 seconds, which is about 5 minutes. Now, the one thing that I want to call your attention to is that at the beginning of this graph, there's a dramatic increase in ethanol production, and really that's just because the yeast themselves have been sitting in a solution of water and they're producing a certain amount of ethanol. So when I take that solution, that yeast suspension, and add it to this chamber, there's a certain what we would call standing level of ethanol or ethanol vapor that's in the chamber. What we're really interested in though is the rate that the ethanol production increases over time. So if you take a look at it right from about here, at about say 150 seconds on, that's really what we're interested in, is the rate of ethanol production. Not this little increase here, but the increase on from about here. So what I'm actually going to do is I'm going to select a region from around 200 seconds to the end here, and I'm going to perform a linear fit to actually get the fermentation rate of the yeast. So I'm going to go and tap on the very top here right at around 200 seconds. And then I'm going to drag across. So I've highlighted that whole region. And then I'm going to tap on this button right here, which is the linear fit button. And there we go. And you can see right here in this little helper box that the slope is about 1.588 ppm per second. If I wanted to convert that to ppm per minute, I would just multiply that by 60. Now, the reason why I really like this activity is because we can actually compare the fermentation rate of yeast to lots of different sugars like galactose, lactose, disaccharides like sucrose. And it's a great inquiry activity that your students can investigate. And it's a really good way to teach your students about sugar metabolism. So let me just show you a file that actually has the fermentation rates of yeast to glucose, fructose, and galactose. And then we have water as a control. Now, fructose is very similar to glucose, and yeast can both metabolize fruit sugar, which is fructose, and glucose very readily. Yeast do not like to metabolize galactose if they don't have to. So I'm just going to open up a file really quick, and I'm going to show you a series of bar graphs that show the fermentation rate, which was taken from looking at the slope that I just showed you, of a small sample of yeast to those different sugars. So I'm going to open up this file. So this is just a bar graph that shows the fermentation rates of a sample of yeast here to glucose, and you can see that the yeast really like the glucose. The rate that they can produce ethanol, and I've converted this to minute, so you just multiply the rate that I just showed you by 60 to get it in ppm per minute. So that's the fermentation rate is well above 100 there. Now you can see fructose is actually close, but not quite as good as glucose. And that's probably to be expected. I mean, you might want to run this experiment several more times to really see if there's a statistically significant difference between these two. What's really interesting is you can see galactose right here. The yeast, for all intents and purposes, couldn't even metabolize it. The fermentation rate is exactly the same. Actually, water is actually even a little bit higher. So we could conclude from looking at this data that the yeast, in this case, can metabolize glucose and fructose, and at least in this case, cannot really metabolize galactose. And those are 3 different monosaccharides. So if you're interested in this activity that looks at the metabolism of different sugars using our ethanol sensor, or using our CO2 sensor, you can also use our carbon dioxide gas sensor to do this same activity. Just go to our website at www.vernier.com.